Hey everyone, in this video we are learning how to make scientific tables, particularly with the formatting that most scientific articles use. So here we've got an example experiment. We're investigating how did the different type of balloon affect the height that it bursts at above a Bunsen burner. So the inquiry question was, what height above a Bunsen burner do different types of balloons burst at? And we're comparing these rubber balloons with those slightly thicker metallic looking balloons. So the independent variable that we're changing in the experiment is the material of the balloon, and that's categorical data in the experiment. And then the dependent variable which we're measuring is the height above the Bunsen burner that they burst at if we were lowering them from above. So you can see here we've done 3 trials of each. This is the height in centimeters that each balloon burst at when they were above the Bunsen burner. So let's work out how we'll design our table. The first thing to plan is, are we going to have our trials in the rows, so trial 1, trial 2 and trial 3, or will we use columns for each trial, trial 2 and trial 3. So in this experiment we only have one piece of data for each trial, so it's probably easiest to have our trials in the rows, and that means the columns can be the independent variable. That's normally what you want to aim for firstly. So our 2 columns are going to be rubber and metallic. I think they're plastic, but they look metallic. And then those are our 2 independent variables. And then we can have our trials as our 3 rows. And then since we're taking 3 trials, you'll always need to take an average, and we'll have that as our last row. All right, that means next, well, these 2 independent variables, the actual measurement that we're taking is the dependent variable. So that's going to be the heading up here. It's the height that it burst at in centimeters. So you only ever put your units in the headings up here. You never put units in here in the actual table. Firstly, because Excel can't recognize units. It can only recognize numbers, particularly if you're doing averages. And secondly, because it makes your tables look neater, and it's the convention when you're writing a table. Okay, so now we have our 3 trials for the rubber balloon, and those data is 32 centimeters trial 1, 29 and 36 for the other trials. The metallic balloons burst at 23, 24 and 26 centimeters. So obviously metallic balloons are a bit thicker and were able to survive the heat lower down until they burst a bit closer. All right, the next thing is to find the average. You can use your numeracy skills to calculate average on your own, or you can use the formula in Excel. So we type in equals to start the formula, then you start typing in average, and it comes up here with all the formulas. And the second one here, average, is what we want to do. So double click it, and then you need to highlight all the cells we want to find the average of and press enter. Okay. If we want to find the average here, you could type out the formula again, or you can use the small box at the bottom of the cell, drag that across, and that copies the formula, but then it uses the cells above it. So that's the average for the metallic. Okay, the next thing is, well, how do we round off our decimals? Well, if we were only using a ruler measuring in centimeters, that's only 2 place values that we were measuring. So our average should really only be in 2 place values as well. We can't be accurate enough to say 24.33 because we were only using a ruler that's not that accurate. So your average should be in the same number of place values as your actual data. Okay. The next thing is, let's make these a little bit wider. For a heading that covers 2 columns, we'll need to merge these cells together. So we'll use the merge and center. And then we'll look at some formatting tips. So scientific tables have a particular format that you generally follow. The first thing is to highlight every cell and click the center. So everything's in the center of its column. Then we always have, or we normally have, a thick line along the bottom of the headings and a thin line at the top. So we're clicking up here. We've highlighted the heading rows. We're clicking up here to show the borders. And then we're doing this one, the top with a thick bottom border. There we go. And when we've used 2 columns that are within one heading, these are called nested columns, we want to have a line underneath that height burst here. So we'll go back up, we'll highlight the height, and we want to draw a line underneath just that cell there, or those 2 merged cells. And so we'll go down to just bottom border, and that will draw a line along the bottom. And there is our finished table. Looking fantastic. You can merge these 2 cells, but there's no information in them. All right. So scientific tables don't have lines in between every row and every column. That's the convention that most scientific journals use. So if we copy this and paste it into a Word document, it's only going to show up with those lines above the rows and the headings. And here's our finished table ready to copy into whatever science report you're working on.